discussing WAAS, LPV, and Data Comm during today's event. Okay, again, good morning. My name is John Spellmeyer. I'm the goofy-looking guy over on the right. I'm the Western Regional Avionics Sales Manager for Duncan. Been in aviation most of my adult life, still fly pretty regularly, and I've got with me Michael Kuzatz. Michael, if you want to introduce yourself.
Hello, I'm the Eastern Regional Avionics Sales Manager, and I do the same thing as John, but I just cover the east half of the U.S., and kind of like John, just not as long, been in aviation for a long time, and we're both fly little airplanes as well, working with all the avionics.
So thanks for your time today. Just a brief introduction to Duncan Aviation. If you're not familiar with the company, it's a family-owned independent business founded in 1956, now in their fourth generation of ownership, locations in Battle Creek and Lincoln, Nebraska, and Provo, Utah, and 27 other satellite shops throughout the U.S. We pride ourselves on our reputation of delivering airplanes on time and doing great work on your aircraft and the family-owned business and the culture that's here. So today we're going to talk about some things related to NextGen. I think you're all familiar with the FAA's efforts over the last decade to implement some next-generation technologies to further increase the efficiency of U.S. airspace. The airports are getting crowded, airspace is getting crowded, and these efforts with the FAA are intended to increase the efficiency and throughput at today's airports. So with that, I'm going to talk about the 5 things that we think aircraft operators should focus on that pertain to NextGen and making the best use of these technologies for your operational flight experience to get the most bang for your buck. So the first one we're going to talk about, which everybody should already have probably addressed, is the GPS WAAS upgrade, wide area augmentation. What this has done is taken GPS and taken it to another level. It's increased its availability and accuracy dramatically based on the ground stations and the other satellite constellations. The availability of GPS has increased on the magnitude of 10,000 times in reliability. It's also made GPS much more accurate to meters in your lateral position, and more importantly, the vertical information that your aircraft's receiving from GPS has been greatly improved, and it's allowed us to implement this capability in the airport environment itself. The FAA now considers GPS so reliable that it's considered a primary nav source, so it's on the level of VOR, DME, TACAN installations in your aircraft. You don't have to have those anymore so long as you have a WAAS-equipped GPS, and it gives you much more options to equip your aircraft.
Let me cut in real quick before we forget. There is if you guys have any questions at all, feel free to just ask those. You've got a little chat bar there. John's going to be working on the presentation. He's the expert on this. I'll be watching questions. So if I find something pretty interesting that we'll need to talk about, I might jump in there. Otherwise, we'll save a lot of the questions for the end. But again, feel free at any point just to throw in a question. Sorry about that.
Perfect. Yeah, thank you. Thanks for bringing that up. So the next thing we want to discuss really briefly is your transponders. And if you're ADS-B compliant, you've got an ADS-B compliant transponder in your airplane, which takes advantage of the accuracy, the improved accuracy of the WAAS GPS. It gives everybody in the airspace the same position source, so everybody's talking about the same position, and we don't have difference in position sources from airplane to airplane to airplane. It allows the ATC controller to see your aircraft outside of radar coverage, so it's better service and better visibility to them. And also with ADS-B out or ADS-B, you can also get ADS-B in some aircrafts with TCAS. It's called TISB, Traffic Information Service Broadcast, or some aircraft have the ability now to use FISB, which is Flight Information Services. That's where you see weather and forecast, METARs, TAFs, NOTAMs, those kind of things are now being digitally transmitted into your aircraft. Another thing we recommend that you keep your eye on, and we've had a couple of webinars about this already, is obsolescence. CRT displays are becoming obsolete. It's difficult to get parts. It's becoming more and more expensive to replace them. The same thing can be applied to inertial reference units, AHRs, radars. The whole group of equipment's reaching the end of its life, and it's becoming either more expensive to repair or it can't be repaired at all. So keep your eye out on that. Flight management systems. This is a key area of the FAA's NextGen. It also takes advantage of the improved accuracy with WAAS GPS, and in that the FMS can now use this to fly GPS-based procedures en route, in the terminal environment, in the approach environment, a whole host of airports. So there are a couple of terms you probably need to be familiar with. One of them is RMP, Required Navigation Performance, also sometimes called PBN, Performance-Based Navigation. And what this is all about is the accuracy of your FMS, how accurate that FMS can be 99.9% of the time in the future is going to determine what types of procedures you can fly. You've heard the term best served, best equipped. If you're best equipped, you get better service, you get preferred routings in and out of airports. It makes the controller's life easy. It's going to save you a lot of time. So RMP, or PBN, performance-based navigation, where you see that today are standard instrument departures, standard stars, arrivals are based on the ability of your FMS to maintain a mile or 2 mile accuracy 99.999% of the time. So you'll see RMP1 SIDS and stars. That means that my FMS can maintain a position accuracy of 1 mile 99.9% of the time, and if it can't, it enunciates and tells me that immediately, and then I can tell ATC and request a different route. So RMP, performance-based navigation. The second thing that the GPS enhancement brings to the FMS is LPV, Localizer Precision with Vertical Guidance. And what this is a GPS-driven precision approach. The first time we've actually had a precision approach using GPS, and we're going to talk about this quite a bit more. Also, towards the end of the Straight Talk presentation today, we're going to talk about data link communications, specifically domestic data link communications that the FAA is implementing. Again, best served, best route, saves time, increases the aircrew situational awareness. It saves time in that you can get digital clearances, departure clearances, rerouting for weather, and geographical weather in the flight deck, which increases the aircrew's situational awareness about the weather out there. So these two items we're going to talk about a little bit in detail, the flight management system upgrades to LPV and data link communications. So you can put your money where you can be best served. So LPV, Localizer Performance with Vertical Guidance, is a GPS-derived ILS for all intents and purposes. Minimums as low as 200 feet for ceiling and 1/2 mile visibility. It uses angular deviation like an ILS. It's funneling you to the runway end. More precise, both laterally and vertically to the runway. RMP SIDS and stars are enabled when we put this into the FMS. So you can fly those type 1, type 2 SIDS and stars and the non-precision approaches into the airport. Unlike non-precision approaches, your FMS is going to be using satellite-based altitude. So your approach, your altimeter, your minimums are not going to be affected by temperature changes. In some approaches, if you'll read the notes, there are temperature limitations, whereas let's say it's -7 degrees Fahrenheit, there's too much error in the altimeter to fly the approach safely. So you have to temperature compensate the calculated decision height or MDA you're using to land the airplane. Other advantages, you don't need a DME, VOR, or ADF. It's not required. The FAA is starting to decommission some of these nav aids. They're going to become less and less prevalent in the future. And the LPV approach isn't affected by snow, signal reflection from aircraft waiting to take off behind the instrument hold line. So lots of benefits to this. The FAA is going gangbusters in publishing these types of approaches. As of 30 January 2020, there's 4,048 published LPV approaches serving almost 2,000 airports. More significantly, There are 1,992 LPVs serving 1,186 non-ILS airports. So we now have almost 1,200 new airports in the country that have a precision approach to at least one runway end at their airport.
That is a huge number.
It is a big number.
Non-ILS airports.
Yep.
I don't think people realize that's that big of a deal.
So LPV approaches now outnumber ILS approaches significantly. And you may go to an airport that has an ILS, but they only have an ILS to one runway. So if the winds aren't favorable, you're going to have to go someplace else to land.
Or try to do a circle to land.
Or do a circle to land.
Nobody likes.
So you will find a lot of these airports will now have LPV approaches. And you see the approach plate over on the right, the vertical and horizontal profile there. The LPV minimums down to decision altitude. Is very similar to an ILS.
Right.
Very similar. So there are several return on investment calculators out there that can help you see the savings both in time and money that LPV can bring to the flight deck. Universal's got a great one. This is what the assumptions I want to talk about, but I actually use their tool to determine the return on investment of doing an LPV upgrade on a 604. Rockwell Collins has also got a return on investment calculator. You just go out to the website. You can find it fairly simply and put in the characteristics, the flight hours of your airplane, and it'll tell you the payback. For instance, we've got a Challenger 604 here. We're assuming they fly 350 hours a year. That LPV an approach is available at their home base, and that an LPV approach is available at approximately 50% of the destination airports that they go to. Average length of the flight, an hour and a half, and we make the assumption because LPV and RMP are available in the FMS, on average that saves about 10 minutes per flight. So if we run through the numbers on the return on investment calculator, we find that we're saving actually 26 hours of flight time a year, which equates to fuel savings of about $46,000, savings on the engine reserve, about $5,900. So in total, you're saving $52,000 a year, which generates a return on investment, i.e. you've paid back your investment 3.5 years to install LPV in an airplane. And after 3.5 years, you're saving $52,000 a year you're putting in your pocket. So this technology does actually equate to savings, both in time, money, and availability of you getting into the airport that you want to more often. So if we look at the major manufacturers out there, our friends at Universal have a whole line of LPV capable FMSs from the 1EW up to the 1FW. A lot of information on their website. On the right, you'll see a little pamphlet they produce. That's a good starting point to learn about this and learn what's available at Universal. It's downloadable from their website. Our friends at Honeywell also have updates to the FMZ 2000 that bring LPV into the flight deck. Provides a lower minima. They also have takeoff and landing data that's available for certain aircraft. Something really cool called Smart Perf, where it actually has performance tables for takeoff and landing data in the aircraft, but it's able to learn through time about actual versus calculated performance data, and a whole lot of other features, which most of these manufacturers, when you do this upgrade, you get things like a faster database updating time, hold to altitude leg sequencing, some VNAV improvements. So it's not just all LPV. They usually throw in some other features and functions that help.
But that's the interesting thing now, because the controllers are expecting you to be able to do that. And yeah, you could pull it off, but it was a lot of mental calculation, and you got to make sure. And now you can drive it with precision.
Absolutely.
To be at the fix, at the altitude, at the time. Yep. And just as long as you know how to drive the system, you don't have to sit there and do mental gymnastics on trying to remember how to do it.
So in the future, you're going to have something called a 4D flight plan.
Yeah.
Which includes time.
Right.
You're going to have to make time to certain fixes. So
yeah.
That's some new developments coming in FMSs as well. And our friends at Rockwell Collins, they have some modernization upgrades that are available to most of the Proline 21 aircraft that provide LPV. Things as faster data loading, more memory in the FMS, step-down fixes, and RF legs, which is a term called radius to fixed legs, which you'll find can be associated with non-precision and precision airports. It's basically a DME arc. It's
Right.
turning around a point at a certain diameter. So those are the three solutions for our major OEM producers, Universal, Honeywell, and Collins. There's a heck of a lot of information out on the website for these, as well as at Duncan, and you've got Michael, myself's contact information. So if you've got any further questions about this, feel free to bring them up today or send us an email. We'd be glad to help you.
And I know we were talking about this earlier, how, especially on the Collins solutions, ProLine 21, where people were sitting there like, hey, I don't want to do a full retrofit to get LPV. And we have been talking to Collins about splitting out the LPV portion of that advance. So Collins is listening, and I think they're looking at some possible programs moving forward so people can get LPVs.
Without synthetic vision and all those things that you may not want.
Right. So Collins has heard you.
So with that, we're going to switch gears here. We're going to talk about Data Comm a bit. Data Comm enables more effective management of airspace, addresses communication frequency congestion, and improves safety. It's essentially texting in the airplane,
right?
Where you don't have the problem of dialect, of static, where you can be absolutely sure that you're having clear, concise, accurate communications.
I heard a great term yesterday. Larry Bartlett, one of the pilots, but been at Duncan forever, said trying to get clearance at Dulles, he called it radio anarchy. He said it's just terrible, and looking forward to the technology like this to just get
around that.
Yeah.
Because with the Data Comm, you can send a lot of information in very short bursts of energy.
Mm-hmm.
You're seeing the necessity of Data Comm, and most of the forward fit installations out of the factory have got Data Comm, and we're doing an increasing number of installations for Data Comm to current aircraft to support the environments that they're flying the airplane in.
Yeah.
This isn't new stuff. Data Comm's been around for over 30 years. It started in the North Atlantic tracks with the difficulties of communicating over HF radio. So the U.S. and Canadian authorities established something called FANS. I think you've probably heard that, Future Air Navigation System 1A. It's called. It's basically a data link communications protocol that uses SATCOM, HF, or VHF radios in conjunction with your FMS to manage clearances, flight plans in the North Atlantic. And now you have to have fans to fly above 27,000 feet in the North Atlantic tracks. It's required. The Europeans have done the same thing. They call it Aeronautical Telecommunications Network Baseline 1B. ATN B1 is the common nomenclature used for it. And now the FAA is implementing domestic fans. Probably another good term for that would be CPDLC, Pilot Controller Data Link Communications. It's not as in-depth as far as training and equipment requirements as fans, but it certainly has its usefulness in the States right now. So these are the key pieces and parts of a data link installation. You've got some kind of enunciator on the instrument panel, audio and visual, that there's a message from ATC. It goes through a communications management unit, a CMU you see down there, which is essentially an interpreter from the comm radio, whether you're using SATCOM, HF, or VHF, to the FMS. It's the interpreter that gathers the information, sends it into the FMS, which then displays a text message or a message to you, or in some cases with fans can actually do flight plan modifications automated in the FMS itself. You've got an FMS CDU to display and respond to messages. Some aircraft have a printer in them, and then some aircraft also have a digital flight data recorder in the aircraft as well. So the FAA is implementing domestic fan functions across the U.S. Right now, there's 62 major airports in the country where you can get a data link departure clearance in your airplane before you tag.
So you're not calling up clearance, pulling, you're just getting it, you just tell them, because So if I understand this right, you get your clearance and then you just call ground and say ready to taxi, correct? I mean,
Correct.
And then you just go.
Yep. Available at 62 major airports in the U.S. Saves a lot of time. I think we've got a slide here coming up that shows you just how much time it does save. But for instance, as of 2 years ago, this is kind of outdated information. There were more than 50,000 data comm operations conducted in the U.S. per week. Clearances, digital ATIS, all those kinds of things. And that's 2 years old. So on average, operators are seeing 10-minute taxi out savings at congested airports.
Yeah.
And in some instances, when there's weather delays, weather issues, it saves up to an hour.
Yeah, I've heard big savings out on the East Coast if you have this technology.
So datacom capabilities kind of come in 4 buckets. You've got those folks that cross the North Atlantic, travel down to Australia, these out far and out places. FANS 1A and ATNB, this a requirement, and in most cases it requires SATCOM. Messaging, we can text messages can be created, saved, and sent via email or air fax. Digital ATIS, Airport Terminal Information Service, arrival, departure, and route information services, graphical and textual weather. Here's some examples of the type of data link weather you can pull into the airplane. NextGen imagery, altitude, winds and temps, icing forecast, turbulence, tops, a weather depiction chart. There's much more than this. Is just a small smothering of the things you can get in the airplane, but improved situational weather awareness. Weather awareness is always important.
Yeah.
And with that, also pre-departure and oceanic clearances. So you can get a whole host of things through data link comm. So our providers, OEMs, they also have a data link solutions. Universal, for instance, has a Unilink UL 800 or -801. It includes FANS capability, but also the lesser required controller pilot data link communications, CPDLC, and something also called ADS-C contract, ADS-C/C contract. And basically this is what I was talking about when ATC is able to interact with the FMS and actually make changes to your flight plan. Okay. Honeywell has a couple of solutions. They have a communications management unit that works with existing VHF radios, or they have a VHF data link capable radio, VDL, VHF data link, Mode 2 radios that allow aircraft to have FANS communications and CPDLC communications around the world. It's applicable to the Falcons, the 900s, the Gulfstream Plainview cockpits, Textron's 560s, Encore and XLS, and Textron's Hawker 800. Rockwell Collins has a CMU/RIU 4000 data link communication system, which provides for transmission of digital data to and from the aircraft over VHF, HF, or SATCOM. It has the ability to pull in weather, the digital weather that we discussed, air traffic control services, two-way text messaging between airplanes or between your ops center and different aircraft. So a lot of capabilities brought to the flight deck with data link communications, and I think we're only seeing the very beginning of this. It's got a long way to go, and we're seeing quite a few customers requesting the capability in the aircraft.
Yeah, I think once they see the benefits, they're going to need it.
So we've got a couple of questions here.
Yeah, Anne, you've got a good question here. She asked, and she pointed out the truth, how an LPV approach is not considered to be a precision approach. And the reason it is not considered to be a precision approach, to be considered a precision approach like an ILS, there's more than just the ILS frequencies. Runway markings, lighting, and all that ground infrastructure is all taken into to count that as a precision approach. Now, for an LPV approach to go down to 200 feet, just like an ILS, they don't have to have those runway markings, lighting, so on and so forth. So the FAA, it got kind of muddy because they didn't know at times an LPV can do everything a precision approach can, but then sometimes it can't. So instead of just trying to figure out when it is, when it's not, it's just never considered a precision approach, even though it takes you down to those same minimums sometimes. And so that's the reason why it's technically not. It doesn't, an LPV doesn't guarantee you all those runway markings, lighting, so on and so forth. So, and a lot of people, another good question is, will the presentation be shared to the participants? And it will be. Everybody who is registered, you will get a link of this. So you'll be able to replay this again.
And I would add, one of the reasons LPV is so popular, and we're seeing so many of them, is just the fact that they don't have to spend so much money on infrastructure to put the approach in. Little airports can literally have this approach surveyed in a day, have it implemented maybe on the next approach cycle of charts, but they don't have to install all the equipment required for an ILS, all the lighting, et cetera, et cetera. It just can be too expensive.
Yeah,
and these little airports.
And it's amazing. A lot of people sit there and go, I never go to a place that I don't have an ILS. And I think, like you, it is starting to become, you're hearing more of the corner cases where, hey, the ILS is down, or you got to do an alternate. I had one about a month ago where the guy's airport was under construction. They were going to redo the runway, so he had to move over to an airport just a few miles away. They didn't have an ILS. So all of a sudden they're like, hey, I need an LPV capability like today. And they didn't have time to set it down. So they're going to, the technology is going that way.
So both these technologies, the LPV and data link communications, are tools that can help you fly more efficiently, make the airports that you want to go to without having to divert, allow you to carry less fuel on board for an alternate airport. There's a whole host of features that make this a good idea and can actually save you money in the long run.
Did we have a poll? I think we had a
couple of questions.
I think so.
You'll see those. You've probably already seen one. If
right.
you take your time to please give us a reply. We're interested in what you think and what you're actually doing with your airplanes. So to close, I'd like to brag a little bit more about Duncan Aviation. We've got 3 full service locations, just opened the one in Provo this year. Lincoln, Nebraska is the other, and the other one is in Battle Creek. We have 27 satellite avionics shops throughout the country. These shops are full capability. They can do anything that they can do at Battle Creek, Lincoln, and in Provo. They specialize in avionics, and they're located all over the country, and there's probably one near you. We have multiple workaway engine sites and rapid response sites that are there to help you with AOG issues.
And I think the big thing there is it's always nice to have a facility close to you to do the work. But even more importantly, it's nice to have a facility close to you when you're out on the road and have a problem. And I think that's the one thing that Duncan provides is just about anywhere you're at, one of our facilities is close to help you.
And I would add to that, in a lot of instances, we'll come to your hangar
to do the work. Very good point.
That happens quite frequently. They'd rather have the airplane in their hangar, and our guys will come to you to do the work when it's convenient for you.
No avionics will travel.
So, Duncan offers a whole host of services, tip to tail, to service your airplane. We sell airplanes, we make acquisitions, we do airframe maintenance, obviously avionics installations. Component repairs is a big part of our business. We do a lot of engine and APU work. AOG emergency services, we're there when you need us. We have an engineering and certification department at our major locations. We do incredible paint and interior work. And we have parts and rotable sales guys that can help you for those hard to find parts that you need. So in closing, I'd like to thank you for 30 minutes of your time today. We hope this was productive for you. Feel free to reach out to Michael or myself at any time. We're glad to help you answer questions. We're glad to help you any way we can. That's why we're here. And if we don't know the answers, we can certainly find them for you.
Sounds good. Thanks for tuning in.
Thank you, folks. Bye-bye.